Hi, Chem 112 students. This is an explanation of Lesson 20-2, the structure and strength of acids and bases. We've already talked a bit about definitions of acid bases, and now we're going to talk about how the structure and polarity and the bond strength is going to affect its strength. We're also going to talk a little bit about the conjugates and their strength. Don't forget that you have to memorize the strong acids. Here they are. There are only 7 of them. HCl, HBr, and HI are the halogenated acids. Don't forget that HF is not considered a strong acid. We'll talk more about that in a bit. You also need to memorize the strong bases. These are the group 1A hydroxides and the heavy group 2A hydroxides. Don't forget that beryllium and magnesium are not considered strong bases in water. So you do need to know these before we go on. We need to talk a little bit about oxides. So an oxide is an element combined with oxygen. If you take an element and combine it with oxygen, you're actually combustioning it. So if I take these are the period 3 elements on the left here, and combine it with oxygen and do combustion, I make an oxide. If I put the oxide in water, hydrolysis happens. Hydrolysis just means reaction with water. And the product is called a hydroxide because it has an O and an H on that substance. We can do an experiment to tell whether these oxides and hydroxides are acidic or basic by putting them in aqueous solution and using an indicator. If I took sodium hydroxide and put it in water, I would find from an indicator that it's a basic solution. Similarly, if I took sodium or magnesium hydroxide and put it in water, I would find that that also is a basic solution. These are both metals. Sodium and magnesium are the active metals in group 1A and 2A. Metals form basic hydroxides and oxides from the active metals. This does not include the transition metals. We'll talk more about those later. The middle section of the slide shows you aluminum and silicon. These two elements are metalloids. They're in between metals and nonmetals. The metalloids have properties of both metals and nonmetals. And if we did an experiment where we put aluminum foil into a solution of HCl, we would find that it would dissolve. At the same time, a piece of aluminum foil would dissolve in a solution of sodium hydroxide. Since aluminum dissolves in either of these solutions, it's got properties of both an acid and a base. An acid would dissolve in a base, and a base would dissolve in an acid, and aluminum does both. That means it has properties of both, and it's amphoteric. And similarly, if we were able to do that for silicon, we would find the same. The elements at the bottom, phosphorus, sulfur, and chlorine, form oxides and hydroxides as listed down below. If we did the experiment and tested an indicator to show whether these are acidic or basic solutions in water, we would find that an acidic solution is formed when P2O5 is put in water. Same for SO3 and Cl2O7. They all form acids. In fact, we can write these formulas in a different way that's more familiar to us. The first one is really H3PO4. The second is H2SO4. And the last one is HClO4. These are all nonmetals. And the general trend is that if you put a nonmetal into an aqueous solution, you form an oxide and a hydroxide. That's an acidic solution. In general, then, we're breaking a different bond. So let's look a little bit more at that. Metals form basic binary oxides and hydroxides. You know that the bond between oxygen and sodium hydroxide is an ionic bond. There's been complete transfer of electrons to the oxygen to form a cation and an anion. Sodium likes to do this because then it forms a noble gas configuration. It's very electropositive, and it's easy to take an electron off of it so that it has an octet or a noble gas configuration. This means it has more metallic character, and in that case, we would form a hydroxide when we put that substance into water. The active metals are group 1A and 2A. The cations are spectator ions, and the oxide and hydroxides are basic. If you draw a trend for these, this is how the ionization energy goes down, and it will form a cation more easily and have a more polar bond to that oxygen. These down here at the bottom left are the most metallic elements. Transition metal cations do not follow the trend of the group 1A and 2A metals. They have some different trends that we'll talk about a little bit later. Nonmetals are on the bottom half of the slide here. They form acidic oxides and hydroxides, and I've shown you the Lewis structures here. These are covalent molecular acids. The red hydrogens are the ones that are acidic, so they're being removed in solution. These are all strong acids. Down below you can see that resonance stabilizes the conjugate base of HClO4. That makes this a very favorable process to remove that proton when you leave something very stable behind.